All right, it's on. You guys ready?
Yeah.
All right. Now everybody's dead quiet. Okay, so listen. We're doing tangent today. You guys have actually already done this. In the other... Put that phone away. Brandon, put that phone away. Now you're embarrassed. All right. Ready? So you got tangent, which we know is opposite over adjacent. That you did last year, right? Yeah. Okay. So all we're doing is applying tangent to all the stuff we've already talked about. Okay? Yeah.
Does the tangent function actually have anything to do with tangent lines?
It does end up being like on the circle in that spot, but yeah, a little bit. Okay? All right, so we are looking for sine, cosine, and tangent for these first couple. So this is basically a review, right? Okay, what do I have to find first? Katie Kirby.
Oh no.
What do I need to find so I can figure out what sine
You
of
need
theta?
to find the side.
The side, right? How am I going to do that?
Like that.
Okay. So a squared plus b squared equals c squared. Fill in for me.
So 4 squared plus b squared equals 5 squared.
Got it. And so b squared is going to be equal to 9, b is equal to 3, b is equal to -3, but -3 length makes no sense. So that's the side is 3. All right, Aiden, sine theta, cosine theta, tan theta. What do I got? Sine theta?
Sine theta is 3 over 5
Good. Opposite over hypotenuse. Cosine theta?
is 4 over 5.
Adjacent over hypotenuse. And tangent is?
3 over 4.
3 over 4. Opposite over adjacent. Alright. Coming over here, right? Same idea? Alright, Quinn, what am I doing?
Find the other side.
Okay, so
A squared plus b squared equals c squared.
fill in for me.
Yeah, so 1 squared plus b squared equals 2 squared.
Okay,
So
b squared equals?
b squared equals 3. So b would equal radical 3 and negative radical.
Right.
So reject negative radical 3.
Got it.
And so that side's radical.
Got it. Alright, so sine of theta would be what, 20?
Radical 3 over 2.
Radical 3 over 2. Cosine of theta would be what, Kirsty?
What is cosine of theta? Like the thingy, the ratio?
So, ka, toa. No?
What's the basis on it?
G.
2 over
Careful, that's called the what?
the hypotenuse.
So what would be the adjacent
1
side?
over 2.
1 over 2, good. Tan theta, Alex.
That would be 3 over 1.
So radical 3, right? Alright, questions on those? So that's your basic sine, cosine, tangent stuff, right? From geometry. Alright, so here we go. Make our final connections here. Back to the unit circle, right? Units, I know this is the unit circle because my radius is 1. And I know that because I'm on the unit circle, technically x would be cosine theta, right? And sine would be y, right? We went over that the other day. Okay, so look, same picture as before, right? But now you're doing tan. Okay, so tan of theta would be equal to what? It would be opposite over adjacent, right? So it would be what? Y over x, correct? Okay, so tan theta is equal to y over x, opposite side over adjacent side. All right, make your final connection then. We're sitting on the unit circle. Instead of saying tan theta equals y over x, we could also say tan theta equals, instead of y, sine theta divided by cosine theta. Okay, so tangent of any angle is always going to equal the sine of that angle divided by the cosine of that angle. Or opposite over adjacent, y over x.
Is that just on the unit circle or in general?
That is actually true no matter what. Okay? Good? Alright, so let's use it. Okay, there it is. So, we should be able to do this without a calculator. We want to find the tangent of 30 degrees. Okay? So we know that the tan of 30 would be equal to the sine of 30 over the cosine of 30, right? And we would draw pictures, because we know how to find the sine of 30 and the cosine of 30, because that's what we've been working on for the last few days. Okay, so 30 degrees is in quadrant 1. I'm going to put myself on the unit circle so that it's nice and easy for me, right? And I know my angle is 30 degrees. That's my theta. It's also my reference angle because I'm in quadrant 1, right? They're the same thing in quadrant 1. So, back to that stuff we had to remember. In a 30, 60, 90, when I am sitting on the unit circle, my hypotenuse is 1. What is the side opposite the 30-degree angle, Jacob? 1/2. And what about the side opposite the 60-degree angle? Radical 3 over 2. And because I'm in quadrant 1, they're both going to stay positive, right? Okay, so that's all stuff. So now what am I doing with this? I'm dividing, correct? I'm taking sine, so tan 30. The sine of 30 would be the y value, so 1/2. So sine 30 is 1/2. And I'm dividing that by the cosine 30, which is my x value. So dividing it by radical 3 over 2. Okay, so you're back to that stuff we did before, complex fractions, right? One fraction divided by another fraction. Actually, you're back to middle school. What do? What's the mnemonic? Skip, flip, multiply. Or put it in your calculator. But actually, you'd be in trouble here because you can't, because it's got a radical, right?
Oh, yeah.
And they're looking for an exact value. So you're going to have to deal with no calculator here. All right, skip, flip, multiply. So tan 30. Skip the top one. It stays 1/2. Flip the bottom one so it becomes 2 over radical 3. And it's no longer division. It's now what? Multiplication. Skip, flip, multiply. All right, how can I simplify this then? What's canceling out? The 2's. One's on top, one's on bottom. They cancel. All right, so now I know tan of 30 is equal to 1 on top, radical 3 on the bottom. Can I leave it like that?
No.
No. So how do I get it to not have a radical in the denominator?
Radical 3 over 3.
Radical 3 and radical 3, top and bottom, right? So radical 3 bottom, radical 3 on top. So final answer, tan of 30 equals radical 3 over 3. Okay, go to your calculator. So you have your calculator on your test on Friday, and you want to check this, right? You've had time, you want to check it, you want to make sure you're right. So I want to type in the tan of 30. A number 1, first thing. What is the angle in? What measurement? Degrees. So go check your mode and make sure you're in degrees. If you're going to use a degree for an angle, you got to be in degrees. And then type in the tan of 30. And it's going to give you a big long decimal, right? Because this is an irrational number that we got. Okay, then what are you going to type in to see if you get the same answer? Radical 3 divided by 3, right? Do you get the same answer? You do, so then you're good to go, right? Check, check. All right, let's do the same thing with tan 45.
Wait, why? Oh, never mind.
You're okay?
Yeah, it's just like, why are we doing this? But then,
Yeah, you need an exact value, right? Okay? So your calculator is more of a check. Plus, you're going to end up showing me work anyways, so I know how to do it. All right, so tan of 45. Draw a picture, correct? You're in quadrant 1. 45-degree angle. Put myself on the unit circle. Theta and theta reference are both 45. Okay, so this is the piece we had to remember, right? When you're on the unit circle, what are the sides opposite the 45s, Carolyn?
radical 2 over 2.
Radical 2 over 2. Both positive because we're in quadrant 1. Okay, so that means the sine of 45 is radical 2 over 2, the y value, and the cosine of 45 is radical 2 over 2, right? And therefore the tangent of 45, sine divided by cosine, right? So radical 2 over 2, all divided by radical 2 over 2. Now, I can skip flip multiply this, absolutely. However, if I have 6 divided by 6, what's my answer? 1. 100 divided by 100? 1. Radical 3 divided by radical 3? 1. What's radical 2 over 2 divided by radical 2 over 2? 1, right? So tan of 45 degrees is equal to 1. You want to skip flip multiply, you're going to get the same thing. Okay, so everything's going to cancel. All right, check in your calculator. Tan 45, can you get 1? Yes. Okay. So really, are we doing anything different? No, you're doing sine and cosine just like we've been doing, right? It's just that you gotta do one extra step to get to tangent. So 150, what quadrant are we in?
3,
No,
2,
2. Okay, so I'm sitting in quadrant 2, 150. I'm on the unit circle, 1. Reference angle is how much? 30. Okay, opposite to 30 is going to be 1/2, right? On the unit circle, opposite to 60 would be radical 3/2. But I need it to be negative so I don't forget that I'm going left, right? The length is radical 3/2, but it's negative. All right, so I know sine, Bryn, sine of 150, what is it?
1/2.
What's the cosine of 150?
Negative root 3/2.
Radical 3/2. And so the tan of 150 is going to be what divided by what?
1/2 divided by negative root 3.
Radical 3/2. So I am going to, are you guys okay if I go right to the multiplication step? So it's 1/2 times negative 2 over radical 3. I'm just skipping showing that division step, right? Make a multiplication, skip, flip, multiply. What happens to the 2's? Cancel, cancel. Tan of 150 equals negative 1 over radical 3. Fix the top and bottom, multiply top and bottom by radical 3. It equals negative radical 3 over 3. Final answer. Which should make sense because over here, reference angle is 30 degrees there also, right? The only thing that should be different is it's negative instead of positive. Yep.
So, why did you put a negative instead of
Because it's going, these are the coordinates of that point right there.
Oh, okay.
And I'm going left. So that I don't forget, I put the negative there. Okay, the length is positive, but I'm going in the direction. That tells me what direction I'm
So
going.
would we like kind of ignore the negative sign whenever it's like that?
Correct. Right, because Pythagorean is just finding length.
Yeah.
Okay? All right, tan of 180. Okay, what kind of angle is 180? Vocab. Quadrantal. So we're not in a quadrant, which means we don't have triangles, right? Okay, so we're sitting at, so yeah, let's look at this. We're sitting at 180 right here, and we want to be able to find sine and cosine of 180, right? So that we can get to tangent. So sine of 180, cos of 180. What's the sine of 180? 0, right? Because the coordinates at that point on the unit circle are negative 1, 0, right? So sine is 0. What's cosine? Negative 1, and therefore tan of 180 would be sine divided by cosine, or 0 divided by negative 1, which is 0. So tan of 180 equals 0. Good so far? Okay. So, keep going here. All right, let's deal with radians. So we want to find the sine of pi over 2 and the cosine of pi over 2. Nothing new. Stuff we've done before. Cos pi over 2. Sine pi over 2, cos pi over 2. Where is pi over 2? Pi split into 2 equal pieces. Yeah. It's on the y-axis up on top, right? 90 degrees. Okay, so if I'm sitting here, pi over 2 is up here. I'm on the unit circle, so it's a quadrantal angle, right? What's your coordinates here? Your coordinates are 0, 1, correct? So the sine of pi over 2, Gwenny, is what? 1. And the cos of pi over 2 is? 0. Questions on that? Okay, so now let's put this piece together. They want me to find the tan of 90 or the tan of pi over 2, right? So tan of pi over 2 or tan of 90 is equal to sine of 90, or sine of pi over 2, divided by cos of pi over 2, which means we would take 1 and divide it by 0. What is 1 divided by 0? Undefined, right? So tan of pi over 2 is equal to undefined. All right, so let's just go to our calculator and see what happens. Go to your calculator. What mode do you want to be in? Radians. So change into radians because I'm going to enter the angle in radians. And type in tan pi over 2 once you're in radians. What's your calculator say to you? It says no good, right? Undefined because you can't have 0, is that what yours says? Okay? So does that make sense to you? So when is tangent going to be undefined? Tangent's going to be undefined when cosine equals what? 0, right? So tangent is undefined whenever cosine equals 0. And that means the only time that cosine ever equals 0 is if you're on a quadrantal angle, correct? That's the only possibility. Everything else, it's going to be between 0 and 1 or 0 and negative 1. All right, so at which of the following angles is tangent undefined? Which of these will make tangent undefined? Well, which one can I eliminate right away? 3, 120. Not a quadrantal angle, out. Right? Okay, how about cosine and sine at 0 degrees? What's my coordinates at 0 degrees? 1, 0, right? And we're supposed to be doing sine divided by cosine, correct? Sine is the y value, so this would be 0 divided by 1. Do I get an answer? Yes, cosine's not 0, so that one is not going to be undefined. How about at 270? What are my coordinates? 0, negative 1, right? Is cosine equal to 0 at 270? All right, then it's going to be undefined, correct? Okay, because the 0 will be on the denominator, and this one will work for us, right? That one will be okay. Questions on that? We're still good. All right. So, determine the value of cosine theta and tan theta if sine theta is 5/13, and the terminal ray of theta lies in the second quadrant. And then find theta's nearest degree. Draw a picture. You guys should be able to draw a picture of that. You should be able to do it, but let's just draw a picture. Get a picture drawn for ourselves, see if we can fill in the diagram based off what they told us. Label theta. Make sure theta is labeled. Get yourself in the right quadrant there. You need to get your quadrant set up, X and Y axes. And now your picture's not drawn right. Where's your terminal ray? Picture. Go. Label theta reference angle 2. Okay, so this is 15/13, and this is 1. We got an option, okay? But otherwise, it's obviously over hypotenuse. It's going to be 5 and 13. Okay? So you want that to be a 5/13, so that's got to be over 1. Okay? All right, so we know we're sitting in quadrant 2, second quadrant. Theta in the second quadrant somewhere, right? Drop my triangle, right triangle, theta reference, inside. Everybody's good there? It looks pretty good there. Okay, so now how does this information help me? I got options, right? Either I'm going to make my radius 1, and my y value is going to be 5/13, or I'm going to treat this as SOHCAHTOA, opposite over hypotenuse, right? What do we want to do? SOHCAHTOA? Okay. So opposite over hypotenuse. So opposite my reference angle would be 5. Hypotenuse is 13. Then I don't have to deal with fractions, right? Pythagorean theorem is going to let me find the other side. A squared plus b squared equals c squared. 5 squared plus b squared equals 13 squared. B squared equals 144, correct? B is 12. B is negative 12. This is length right now. So I'm rejecting. So this is 12 long. However, what am I going to do to it? Put a negative only because of direction, right? Just so I don't forget. Okay, but it's not to do with this. Not the same as this negative over here. All right, so the coordinates of this point on the unit circle would be negative 12, 5. Oh, no, sorry, not on the unit circle. Take that back. On the unit circle, it would be negative 12/13 and 5/13. All right, so we want to find what? Cosine theta. All right, cosine theta, Katie.
It is negative 12 over 13.
Negative 12 over 13, adjacent over hypotenuse. And tan of theta Aiden?
Tan of theta is 5.12.
Right, negative, correct?
Yes.
Okay, so did I have to do sine over cosine for this one? No, because I've got my triangle, right? I'm going to that opposite over adjacent. Are you guys with me? Don't need to figure out sine and cosine in this case, okay? So you gotta be able to think different things. All right, we got this. Final step, I need to be able to find theta, right? Is your calculator gonna give you theta directly? No, what do you need to find? Reference angle. Okay, so theta reference. How am I gonna find theta reference? Give me one possibility. There's different ways I could do it. Quinn?
Inverse sine.
Inverse sine, okay, so inverse sine of
5/13.
5/30, it's already positive, right? So I don't have to worry about that. If I use one of these, then I need to make them both positive. All right, so you go to your calculator. What'd you get for your reference angle, Quinn? Nearest degree. Are you in radians?
Oh yeah, my bad. Alright, nearest degree is 23 degrees.
23. Usually if you're in radians, you're going to get something weird that doesn't make sense to you, right?
40.
Okay, so 23 degrees. How do I then find theta? What they really want. They don't want theta reference, they want theta. What do I have to do?
Subtract it from 180.
180 minus 23.
Yeah.
So final answer?
157.
157?
Yeah.
Okay, final answer, 157 for my theta. So if you wanted to check yourself, you'd be off a little bit because we rounded, but the tan of 157 degrees, if you make sure you're in degrees, should equal negative 5 divided by 12. Okay? You might be a little off because of our rounding, but it should be pretty close. All right, last thing here. Remember when we went back and we figured out what quadrant we're going to be positive or negative? Right? Anybody do cosine for me? Cosine in quadrant 1, 2, 3, and 4. When is it going to be positive? When is it going to be negative? Am I picking? Oh, Jacob.
Alright, so positive in 1.
Positive in 1 because it's the x value, right? You're going to the right. 2?
Negative.
Negative because you're going to the left to plot a point. Yep.
Negative.
Negative because you're going left again to plot a point.
And positive.
And positive. Everybody with Jacob on that? Plotting our points. All right, Carolyn, what about sine?
Positive,
Positive because you're going up, right? Quadrant 1.
positive,
Positive going up to get to quadrant 2.
negative,
Negative. Negative. Down both of those cases. All right, so should we be able to figure out tangent then? Yes, because what's tangent equal to? Sine of theta divided by cosine theta, right? So what are we really saying? If I take a positive and I divide it by a positive, what do I get? Positive. If I take a positive and divide it by a negative, what do I get? Negative. Negative divided by negative. Positive. Negative divided by positive. Negative. So tangent will be positive in quadrant 1 and quadrant 3, right? And negative in quadrant 2 or 4. If you type in tangent of 150, will your answer be positive or negative? Negative, because you're in what quadrant? 2, right? 150 is in quadrant 2. Are you guys following that? Okay, are we done? You guys did great. Bye, everybody.
That was the most unenthusiastic bye.
I think it's still on.
Oh,